Okay, students, now let's move on to another few concepts pertaining to binomial distribution. Okay, we'll look at how are we going to find the mean and variance of a binomial distribution. Okay, if you have a discrete random variable x and you are told that it follows a binomial distribution with parameters n and p, okay, then how are we going to calculate the mean of x? Mean of x is also known as expectation of x. So it is n times p. Alright, in other words, number of trials multiplied by the probability of success. And variance of x, okay, short form is VAR, bracket x, the formula is MP times 1 minus p. Alright, where 1 minus p is also equals to q. Alright, so sometimes we can write it as MP times 1 minus p, or sometimes we can write it as MP times q. Okay, so once we have the variance of x, then we can easily calculate standard deviation of x, because standard deviation of x is actually just the square root of variance of x. So in other words, standard deviation of x, the formula is the square root of n times p times q. Okay, so now that we know how to calculate these three things pertaining to a binomial distribution random variable, mean of x or expectation of x, variance of x, as well as standard deviation of x, let's look at some examples. In example 4, you're told that probability that it will be a rainy day is 0.6, and you're asked to find the standard deviation and standard deviation of number of rainy days in a week and expected number of rainy days in a week, as well as state an assumption that you need. What do you need to assume in order to work out the expected number of rainy days and standard deviation of number of rainy days in a week? So the assumption, you need to assume this: the weather condition on any particular day is independent of the weather condition on any other days. Okay, so independent. So this is the condition of the trials are independent. All right, but to fit it in this case, you fit it into the context of this question to become an assumption. Okay, you need to assume that the trials are independent, which in this case, you assume that the weather condition on any particular day is independent of the weather condition on any other days. Okay, so we define random variable x as number of rainy days in a week. So x follows a binomial distribution with n 7 because there are 7 days in a week, and then okay, so this is your n is 7 and p probability that a particular day will be rainy will be 0.6. Okay, so expected number of rainy days in a week is expectation of x. So formula is n times p. So 7 times 0.6, you get the answer 4.2. Okay, do take note. In this case, because we are finding expectation. So expectation or expected number is actually a theoretical number. So therefore, it is alright that this value is not a whole number. Okay, so you do not need to round this off to a whole number unless the question states otherwise. Okay, states so. Otherwise, just leave it as a non-whole number. It is fine because this is just an expectation or expected value or mean of a random variable which follows a binomial distribution is just a theoretical value. Okay, so likewise for standard deviation and variance of x. Okay, so standard deviation will be square root of variance of x, which is square root of MPQ. So you just sub in the values and key into your GC, round off to 3SF, 1.30. Okay, so again, it's fine that this is not a whole number because it's just a standard deviation or variance, just like expectation, are just theoretical values. Okay, let's look at example 5. In example 5, we are told that a random variable x follows a binomial distribution such that x follows a binomial distribution with parameters n and p. You are given two information and you are asked to find n and p. So the first information is that mean of x is 2.6. In other words, expectation of x is 2.6. So we know that expectation of x is n times p. Okay, so that is equals to 2.6. And we are also told that the variance of x is 2.08. So we know that the formula for variance of x is actually n times p times 1 minus p. okay, equals to 2.08. So we call this equation 2. So now, to solve for n and p with two equations, we can easily solve. So one way will be to sub equation 1 into equation 2. So n times p, we know it's 2.6 from equation 1. Alright, so we just replace np by 2.6 in equation 2. And we can easily solve for the value of p to be 0.2. Okay, once we have solved for value of p, we can easily solve for the value of n. So just sub p equals to 0.2 into equation 1. So n equals to 13. Okay, so in this case, x follows a binomial distribution with parameters n is 13 and p, probability of success, is 0.2. Okay, so that is just an illustration of how do you apply the formula to find mean of x or expectation of x as well as variance of x, okay, as well as standard deviation of x, okay, where x is a random variable where you're told that it follows after a binomial distribution. So now let's move on to another concept, which is how are we going to find the mode of a binomial distribution. Okay, so if you are told random variable x follows a binomial distribution with parameters n and p, then the mode of x will be the value of x that is most likely to occur. Okay, so what does it mean? So the value of x that is most likely to occur means it will actually has this particular value of x will actually has the highest probability compared to all the other probabilities of x, that random variable x take on different values. Okay, so this particular value of x that random variable x takes on will have the highest probability. So therefore, you will have the highest chance of occurrence, most likely to occur. And therefore, this particular value of x is called the mode of a binomial distribution. Do take note that sometimes in reality, there can be more than one mode because there can be more than one value of x with the same highest probability. Okay, let's look at some examples. In example 6, we are told, okay, so 80% of the inhabitants are known to have an eye disorder. So that means P is 0.8 if we are talking about number of people with eye disorder. Okay, and then 12 people are waiting to see the doctor. So this is the value of n, number of trials. You are asked to find what is the most likely number of them to have the eye disorder. So we define x as number of people who have an eye disorder out of 12 people. Okay, so n is 12 and p is 0.8 as what I've just explained above. So to find most likely number of inhabitants to have the eye disorder out of that 12 people, that means we are finding the most likely number, means most probable value of x, means the value of x with the highest probability or greatest value of probability x equals to that particular value. So how are we going to use our GC to find this? So the GC steps are as listed here. Okay, so let's try out. Okay, so we will first go to y equals to, okay, make sure you clear your GC first and then we input. So we want to find, we are finding each particular value of x. So therefore we will use binom PDF. Okay, so for this question, our n is 12 and our p is 0.8 and x value, we'll just leave it as x, right? Because we want to find each particular value of x. After we have keyed in into y1, now we can go to table to look at the values. So we're interested to see which is the value of x that will cause y1 to be the greatest value. Okay, so you notice the value of x, the value of y1 keep on increasing until this point where the value of y1 is the greatest, which is 0.2835. Okay, 0.2835. Okay, corresponding to x equals to 10. So therefore, this value of x, which is 10, would be the mode or the most likely number of inhabitants to have the eye disorder. okay, corresponding to this question, because this value of x is 10 has the highest probability, okay, among all the various probability, okay, from s equals 0 to s equals to 12. Okay, so therefore we'll copy this row in the center row and then copy one row above and one row below, okay, into our solution. So yeah, okay, so therefore what will be your presentation? So you do not need to, in your presentation, you just need to write down, okay, this part, define random variable x, and then write down its distribution. Then after that, you will, okay, you will write down this part using GC, okay, and you will need to write down these three rows, okay, of for the three different probability values. Okay, so you know that the correct answer is x equals to 10, so you put it in the center row and then you copy one row above and one row below. Okay, the different probability value corresponding to different values of x. So we can see that the highest probability is for it occurs when x equals to 10. So therefore, the mode or the most likely number of people among the inhabitants of 12 people to have the eye disorder will be 10. Okay, so this conclusion is important. You need to write down this conclusion. Okay, after you've written down the three rows that you obtain, the values that you obtain from the GC. Okay, so all those rows that I put an arrow means all these will be your will be the essential working that you need to write down in your presentation in solving this question of finding mode of a random variable which follows a binomial distribution. Okay, okay, let's look at another example, which is example 7. So it's a very short example. You're told that random variable x follows binomial distribution such that x, okay, parameter n is 5 and parameter p is 0.5. So you're asked to find modes of the distribution. Okay, um, so you can use GC to key in. Okay, so if you use GC to key in, you will see that. Okay, let's clear this. Okay, and then let's input again. So again, to find mode, we are always using binom PDF. Okay, so n in this case is 5 and p for this example 7 is 0.5. X value, small x value is still x. Okay, okay, so now you can go to table again, and what do we want to find from? So we are concerned with x from 0 all the way until 5. Okay, you notice the value of y1 or probability keep on increasing until x is 2 and x is 3. So x is 2 and x is 3, they have the highest probability. Okay, and in fact they have the same highest probability. So therefore the modes of this random variable x will be x is 2 and x is 3. Okay, 2 and 3. Okay, because these two values have the same highest probability compared to other values of x, okay, that x can take on. Okay, so in this case, you will just write down using GC. So since there are two values of x, two different values of x with the same highest probability, so you can just write down these two uh, probability values. So after you use GC table, we realize that probability s equals 2 is 0.3125 and probability s equals to 3 is also 0.3125. Okay, so therefore modes are 2 and 3. Okay, so therefore the modes are 2 and 3. Take note, the modes will be the values of x, not the values of the probability, okay, corresponding to that value of x. So modes is referring to the value that small x can take on, okay, I mean a random variable x can take on, okay, and it is the small values of x. In this case is 2 and 3. All right,